Jim Shaw here for another unique Gem on Engineering. I'm again joined by Alan High, Will Byers, and Mike Steffen to discuss what is happening on a motherboard. Mike, can you kick us off by describing the Platform Controller Hub, or PCH?
Well, the PCH kind of takes over a lot of the functions that the CPU doesn't want to bother itself with. So it's taking over all the legacy I/O, the slow stuff that no longer makes sense to go within the CPU itself. For instance, SATA, USB 2, USB 3, GPIO, basic system functions. Can handle the buttons and the LEDs and stuff. The things that the CPU doesn't need to bother itself with is what the PCH is really designed for. And it can also host a number of PCIe lanes to extend the I/O capability of the board if the CPUs themselves cannot provide enough for all the slots. A lot of different functions.
I think one of the other things it does is it's kind of the gateway to the BMC, right? It basically is the connection to the BMC.
There's a lot of hooks, and we'll get to the BMC in a moment.
Yeah.
There's a lot of hooks that the BMC needs access to that are coming from the PCH and coming from the bus that the PCH has access to. So they do share quite a bit of I/O.
Okay, and somewhere in here is the intelligent, the management engine, the Intel management engine. Yes, and that's now kind of been claimed by the PCH, right? It's pulled into that silicon.
That's where it lives, yeah.
Correct. Okay. The management engine is an Intel function where it can basically do some remote management features at a station, that sort of thing, by the network, and then that all lives most likely, or in all cases, basically in the PCH at this point.
Okay, and then power management is the other thing that the PCH basically kind of accommodates.
And that would be power state of the entire system, as in power on, power off, booting up the system. I know the BIOS is all connected to the PCH, and so that's basically how the system turns on and off and manages the power state of the system is done a lot through the PCH.
Maybe we could move on to the baseboard management controller, the BMC. Anyone want to take that?
Sure, I'll start with the BMC. So the BMC is kind of an interesting function on these boards. Typically, you'll find these more in server motherboards that need remote management of some kind. And basically, it's a small computer for your computer. It has a network interface and typically a web GUI or some sort of API to communicate with the BMC itself, and it does remote management for the rest of the system. So it can monitor voltages, temperatures, fan speeds, all that good stuff. It can provide remote video access. So it actually provides, in most cases, a video adapter to display video off of, and then it can either get a picture of what's being displayed out of that video device, and then allow a remote administrator to then see what's on that screen, or connect a keyboard and mouse to it and remotely administer the system. So it has a lot of hooks into the motherboard to be able to provide basically an administrator information about the system and its current state.
Okay, so let's see. It provides remote access, the ability to do remote access, and with a lot of these platforms, we call that IPMI.
Correct. And that would be the standard that is used throughout the industry. There's a variety of other manufacturers that make these IPMI devices. You know, you'll hear iDRAC, or HP has ILO, or there's a variety of them that all use this same IPMI functionality.
So you can do remote management, but it's also kind of a health monitoring computer.
Correct.
It kind of is looking for voltage sag or temperature overloads, or communication buses, a bunch of different things that it can do. So it's a little bit of a chip nanny.
Yes. It's the computer for your computer,
Yes.
so you can basically monitor everything that server may be doing. And that's really important, say, for huge installations of systems where you may not have immediate physical access to that system. And so you would want to just log into it remotely, and you can turn it on and off and manage it however you want.
Yeah, so it really contains a capability that you don't normally find in a workstation or a normal computer.
Correct.
And that's because these are not used in those ways.
Correct.
Right? It's a much larger system that's usually managed by an IT professional or
Yep.
A sailor, soldier, or airman that has the need to remotely manage these types of applications.
Correct, and there are some obvious security implications because of that, and so that's something that kind of IT professionals just need to manage in their networks.
Okay. Well, speaking of security, maybe we should move on and talk a little bit about the Trusted Platform Module, the TPM.
So the TPM, the Trusted Platform Module, is a specialized chip or specialized module in a lot of cases that is either pre-installed on the board or is available as a module that you can add on yourself. And what this does is it's the most trusted piece of the computer. It's designed specifically, the way the chip is designed, to be very hard to hack, to be very hard to interact with from the outside, tamper with. So that's where, as far as the system's concerned, it's the vault for everything else. It's the most secure place. So you store all your encryption keys, you store your drive keys, you store any information that you need to be able to validate that the rest of the system is installed and operating correctly. You have to have some root of trust there, otherwise you can't validate. You can't validate two things you can't trust against each other. Mm-hmm. So you have to have some central place you can trust, and that's what the TPM provides as a centralized place for that to be stored.
So the TPM, in order to get to the TPM, you have to have a key to get in. Correct?
Yeah. The TPM is sitting on the LPC bus usually, and it's communicating very very low level with the PCH in the startup sequence for the CPUs, and the CPUs can ask it, is what I'm doing correct? Is the image I'm providing you correct? And it can provide cryptographic responses. Yes, you are trying to run valid software. Yes, you're trying to unlock the right drive, and that sort of function.
Okay. I like the way that you described that, Mike, as a vault. It's there's a combination to get into the vault, and the keys are inside, and for all the other pieces of security that are inside.
And we kind of talked about it earlier with some of the boot processes that are being implemented on the software side, and that interacts directly with the TPMs to be able to verify that your hardware is good, basically.
We're seeing a lot of these TPM chips that are being soldered down now, which seems like a good thing.
Yes.
With respect to in years past, they've been just a module you add on.
It makes it a little bit harder to remove from the board.
Yeah. Mm-hmm. So at Crystal Group, we tended to, if we have those kind of modules, they're attached in a manner that prevents their removal. Mm-hmm. So, cool. Great discussion on TPMs. Maybe we could talk a little bit about things like there's a network controller on the board, and how many different kinds are there, and what does it do?
Alan, you want to?
How many different kinds is a bit of a loaded question, I feel
Yeah. So a little vague. So usually we have a 10 gig, a 1 gig.
So
we can do
So it kind of depends on the board in question or what you're looking at. But basically, you've got your network controller that connects your system electrically to another system or systems, and kind of a good rule of thumb when you look at a board is if it has a heatsink on it, it's going to be pulling more power. One of the cues is typically the higher speed network controllers pull more power and thus have a big heatsink on them. I believe this one is like right there. And basically, the kind of standard right now is kind of going to 10 gig if it's not 10 gig already. But you'll frequently see a lot of 1s and 10s in modern boards today. A lot of times, there's a variety of manufacturers of them. It's typically, you'll see Intel or Broadcom for network controllers, and they're network controllers. I don't know. So some of them could be fiber, some of them could be copper.
So sometimes you'll see an SFP, a cage,
Yes.
on a board, and that allows you some latitude in terms of what you can plug into it, whether
Correct.
that be copper, fiber.
Correct. That just provides basically an interface. The SFP provides an interface, so that way you can provide any sort of physical interface into that you would like.
So bottom line is we're seeing a trend in the industry where we're transitioning from 1 gig interfaces to 10 gig interfaces. And so we kind of expect to see more of that to
Yes,
come.
I would expect to see it get even faster sooner than later, as well as 10 becomes the default base level.
Yeah. I think we could do a whole podcast on memory, the various types, what you're trading, the ranking, things like that. But maybe you guys could talk a little bit about ECC and registered, buffered, those kinds of things, the DDR types, so that kind of give the audience a little background about what's going on with memory.
So DDR stands for dual data rate. So that means that it does a data transfer on both sides of the clock. This differs from the old SD-RAM standard that did only half of that, did one transfer per clock. So then we're talking back in the 2000s where that transition happened. So now we're at DDR5 on the newest platforms. The physical interface has been the same for a little while. It's a 288 pin card edge on the module. There's a number of DRAM chips on the module. In the case of ECC memory, it's RAID for memory.
Oh, okay.
Yeah.
So you're basically either you're striping or there's a parity
There's enough extra data bits there to be able to check.
to
Yeah.
to then reassemble the data should you drop.
That's called single bit correction. Yeah. So that's ECC. There's also double bit correction for more intensive applications where that's more likely or more troublesome. You can also have ranked DIMMs. You can have buffered DIMMs. Other areas where you can have different configurations of chips with different circuitry to either adjust the clocks or reduce the load on the memory bus. That's FBDIMM, a buffer. What is FB?
Fully buffered,
Fully
I believe.
buffered.
Yeah.
So depending on the type of memory you're trying to, or depending on the amount of memory you need and the speed you need, the CPUs you're using in particular, and the either the speed or the capacity, the number of channels that you have there. There's a lot of different options that you can put in for those modules.
And I think that's a good point of bringing up the CPUs, because the CPUs are what define what memory is compatible with your system. So typically the memory controller is now on the CPUs. In the past number of generations it's moved that way, and then that defines what memory you can use. So if you need ECC memory, if you need fully buffered DIMMs, those types of things are all defined by the CPU at this point.
So in a lot of cases where our customers want ECC, that kind of drives you to a Xeon
Correct.
D or higher class of
Correct.
platform.
You need a Xeon. Basically, the Xeons are the ones that support ECC memory, or the equivalent on the AMD side. But yes, the CPUs need to support that memory for it to function.
So I think that's a key point, that it's, all these different options aren't available everywhere.
That's correct. There are new technologies that Intel, AMD are coming out with, which they can do ECC memory in band, which I think you basically lose a little bit of total memory availability. So say you have 32, you have actually access to 29, and then you also, I think, lose a little bit of speed, but then you gain that ECC memory error correction. So
Cool.
there are some benefits there.
Yeah. A lot of great discussion today, and we still have more to come. Join us next time as we cover more chipsets and trends we see happening in the industry.